Welcome friends to Get Educare, a complete online tutorials for GATE, IAS, government jobs for electrical and electronics engineering students. In this video, I will explain the basic operation of transformer. If you missed my first part, please go through that video. End of this video also, I will giving the link. As I am explained in the first video, whenever I apply an AC voltage V equal to Vm sin omega t, then a current will be drawn from the supply. This current is called I mu magnetizing current. Due to alternating nature of magnetizing current, a flux will be produced into the coil, and this flux will go through the core of the transformer, which links the secondary winding also. This is the flux phi of t. Since flux phi of t is the phi m sin of omega t, flux changes with time. The conductor of primary coil feel the flux which is changing with time. Therefore, an EMF will be induced into the conductor of the primary winding. The secondary coil also feel the flux which is passing through the coil. It changes with time. Therefore, an EMF will be also induced in the secondary coil E2 also. If the primary winding has N1 number of turns and the secondary winding has N2 number of turns, then we'll see that we can drive a relation that will be explained in our later videos. The E2 and E1 is the N2 by N1. Now, depending upon the number of turns of secondary winding and primary winding, E2 may be greater than E1 or E2 may be less than E1. If the secondary voltage E2 is greater than E1, then it is called step up transformer. If the secondary voltage E2 is less than primary voltage E1, then it is called step down transformer. Once the transformer is constructed, depending upon the number of turns N1 and N2, the winding LV winding, low voltage winding, is fixed, and high voltage winding is also fixed. The winding with less number of turns N1 is called LV winding. The winding with more number of turns, suppose N2. Here N1 is less than N2. Let this is the transformer and it has a N1 number of turns and this winding has N2 number of turns. Here N1 less than N2. Then since this winding has less number of turns, this winding is called LV winding, low voltage winding, and this winding has more number of turns. This winding is called high voltage winding or HV winding. Now, if I apply a voltage here in the primary, then this LV will act as a primary winding, and this will act as a secondary winding, and load will be connected across the secondary winding. But if we do the reverse, that means this is a LB winding, this is HB winding, has N1 number of turns, N2 number of turns. But if we apply the voltage here in the HB winding, then this winding will act as a primary, and this voltage, but this winding will be act as a secondary, and load will be connected here. So we can conclude, for a transformer, once the transformer is constructed, the low voltage winding and high voltage winding is fixed, but the primary winding and secondary winding is not fixed. The winding with less number of turns is a low voltage winding. The winding with more number of turns is the high voltage winding. The winding at which we apply the supply voltage act as a primary, and the winding to which we connect the load is act as a secondary. Here this is primary, LB is primary, but here HB is primary. Here if we apply a voltage here, this will act as a primary, and if we connected a load here, this will act as a secondary. This is also called input terminal, this is also called output terminal. If we neglect the losses of transformer, then input power equal to the output power. Therefore, transformer cannot generate power. The input power will be the output power. It cannot generate power, it only transmit power. I can write down transformer is constant power device. Again, if the input frequency is F, then output frequency will also be F. It cannot change the frequency level. We can say that transformer is also a constant frequency device. Again, for proper operation of transformer, the required flux is constant. We'll see later videos. Therefore, we can say that transformer is also a constant flux device. Here the input energy is electrical and output energy is electrical. So with respect to external terminal, there is no energy conversion, electrical and electrical. But in terms of internal circuit, this electrical energy is converted into magnetic energy, and magnetic energy is also again converted into electrical energy. So in terms of internal circuit, there is a conversion of energy inside the transformer. Classification of transformer. Based on construction, transformer can be classified into two categories. One is core type transformer, and that is shell type transformer. We'll explain in the next video the construction of core type and shell type transformer. Based on number of winding, there are three types of transformer. That is single winding transformer is also called auto transformer, two winding transformer and three winding transformer. Based on frequency, the transformer can be classified as single phase transformer and three phase transformer. Based on power system application, there are two types of transformer. One is distribution transformer used for distribution of electrical power. Another is power transformer which is used for transmission of power. Based on operating frequency, transformer can be classified as power frequency, whose frequency range is 25 Hz to 400 Hz. And another frequency transformer is audio frequency transformer. The frequency range is up to 20 kHz. with the based on measurement application, it can be classified as current transformer and potential transformer. In the power system network, the current is very high in the range of kiloampere. Suppose 10 kiloampere. This amount of current cannot be measured with the help of normal ammeter. Therefore, with the help of current transformer, I reduce the current level and measure the current. Similarly, for measurement of high voltage, we use the potential transformer. Based on electronic application, transformer can be classified as isolation transformer, impedance matching transformer, and pulse transformer. Isolation transformer is generally used in power electronics application. The power electronics device is SCR or thyristor. There is a anode terminal, this is cathode, and this is the gate terminal. Here from anode to cathode the power is very high. Suppose the current is 10 kilo ampere. 10 kiloampere is current is flowing. Gate terminal is used to switch on this thyristor only. Once the thyristor is switched on, the gate has no control, and gate triggering circuit is very low power circuit. Now by chance if this SCR becomes damaged or fault, then this huge amount of power goes to the low power gate triggering circuit and it will be damaged. Therefore, to protect this low rating gate triggering circuit from high rating of anode cathode circuit, we use a isolation transformer here. If this SCR get damaged, then this isolation transformer will be damaged, but it will not damage the gate triggering circuit. That means for protection of purpose, we use isolation transformer. The isolation transformer turns ratio N1 by N2 is 1:1. It does not increase the voltage or decrease the voltage. Input voltage is the output voltage. Here the purpose is to protect the low power circuit from high power circuit. Now impedance matching transformer. Suppose this is a source side and this is the load side. As we know from maximum power transfer theorem, the impedance, when the source impedance is equal to the load impedance, then maximum power will be transmitted from source to load. If there is a impedance matching between source and load, the power will be the maximum and the purpose may not be fulfilled. For impedance matching, we connect a impedance matching transformer to the load side so that the impedance of source and impedance of load along with impedance matching transformer becomes equal and maximum power transfer happens. For pulse transformer, we use for generation of pulse. Please subscribe my channel so that you don't miss any new videos and notification. Also like and share the video to your friends. I will try my best for upload the more useful videos for you for your exams. Thank you.